Hello, Dr. Ron England, and I'm going to go over retention and exfiltration specifically here using SMADA Online. So if you've got an account on SMADA Online, smadaonline.com, and you go into the selection of pollutant analysis routines, you'll see that one of them is exfiltration. Exfiltration works very similar to the way that retention works, in that you can create exfiltration systems, save them, update them, and edit them. So we're going to look specifically at a sample exfiltration that I've created right here. I'm going to go to the edit screen. And before we actually start into the exfiltration itself, let's talk a little bit about what this actually is doing. Exfiltration is a storage-based solution. So what we actually have to do in this case is calculate the amount of storage that you have. This is done, you can see here, through a typical exfiltration system. You've got a large square box here which has a width and a height. Inside of there you have a pipe which the water is going to come through, and in the middle you're going to have some sort of aggregate that is going to be able to store water but also serves as a surrounding to this pipe. So to calculate this amount of storage, we would actually enter the information associated with this. That would be the pipe span, the pipe rise, the pipe length, the trench length, the width, and the depth of the trench. All those are just basically geometric parameters that allow you to calculate the amount of volume that you have. And the only last parameter that you have is an aggregate void ratio, basically looking at the fact that the pipe is going to be backfilled with some sort of rock. How much of that rock is actually going to be rock, and how much of that rock space is going to be water. Once you have those parameters, you have the ability to calculate a specific amount of retention that's involved here. To calculate pollutant removal efficiency, it's a simple calculation using the curves that were generated as part of the BMP trains model to calculate the efficiency. Those curves rely on the total area of the catchment itself, the non-directly connected impervious area curve number, and the DCIA percent. If you've previously created a catchment in here through the edit catchment or watershed, you have the ability to use an existing catchment, and it will use the post condition of that catchment. So for example, if I wish to use sample catchment 2, it will use those parameters. It will override the zone in the catchment parameters that you see down here and use the ones from sample catchment 2. Once you're done, you would enter the information that you have. You would click the calculate button, and you're going to see a calculation of those individual parameters that are associated with this. In this case, we've actually got a retention volume using the parameters that I entered of 1.2 acre-feet. And what that actually comes into as a treatment volume of the inches over the watershed is 1.44 inches over the watershed itself. This, using the BMP trains curves that rely on the Florida zone and the watershed parameters, you'll get a calculated treatment efficiency. Once you've created this, you have the ability to, now this is one that I had previously created, so I have the ability to update it with any information that I might have changed, or if I click save, it will save it as a new file, and I'll have actually, in this case now, 2 exfiltration systems that are in my parameters here. When you're done, you can click done. Also, you have the ability to, if you've logged in, to go to a report format of this, where it will actually show this in a printable or copyable version. Thank you very much. That would be the basics of exfiltration.